or more control rather over your devices that are connected there. Now, with one of the disadvantage with you having a series circuit, is that it can damage your appliances in a sense where you would have like a voltage drop. You understand, right? So that can in turn let your devices not being able to function efficiently. You know, can I move along a little bit here?
Yes, sir.
All right. Now, we want to talk about a fuse. Have we ever heard about a fuse before?
Yes, sir.
All right, tell me what you know.
Not much. They always talk about it, but I don't really know anything.
What do they always talk about it and say?
Is that they always use it in like when they like if like an electrician comes to my house, we always say that he's gonna have to use a fuse to like fix something for some safety reasons. So I
Mm-hmm.
don't know.
All right, fair enough. Anybody else want to say something? So typically a fuse
They
is a.
always talk,
You want to say something? Go ahead.
I'm saying they always talk about a fuse being blown or something.
Yes, yes, that's the word I'm looking for. Yeah, yeah, right. And we're gonna see how that happens now. In real life or in physics life. Now, so a fuse basically is a safety device. You understand that is built in such a way that there is a piece of a wire inside of the casing, right? That wire is built using different type of alloys that would whenever a certain amount of heat is applied to it, right? Once it exceeds the expansion coefficient, or the heat expansion coefficient, then it will break, right? And with it being break now, it will basically short the circuit, or you would have an open circuit. So there you can refer to it as an open circuit or short circuit, right? But based on what's on my screen here, they said a fuse is always connected in series with your components, and that is essential because if you have, say for example, a really nice component in your circuit, and a very expensive component, and you don't want, because of some voltage or some short circuit in your circuit, you don't want that component to get damaged, right? No, you have to.
Uh,
Yes.
I have a question.
On.
Um, if the fuse is used to protect the circuit from overcurrent, how is it that it get blown so easy?
How is it that you get blown so easily? We're going to
Yes.
look. We're going to look at that. All right. Just because we're going to talk about that a little bit. But let me see how best I can explain it in a sense. So when you have it in series, right? Once the current reaches above the limit of that component, right, or above the limit of what the fuse is rated at, it's going to now break the wire inside of the fuse. And if you can see on my screen here, this thing here is what a fuse look like, right? Now there are two different symbols. This is going to be one of them that we'll talk about, right? Where you have this squiggly looking wire, right? That is, so basically that is the piece of wire inside of it. Now it is connected in series with my battery source and my resistor. Now if there was like a short circuit here, or where this end of my wire, right, was broken, and it is and they start touching each other, right, there's going to be a built up of current in your circuit. And with that happening now, the fuse can only take so much or no more current, right? When we talk about fuse rating, each fuse is designed to accommodate a certain number of current. So you would see them saying a 1 amp fuse, 5 amp, whatsoever it is. So if you realize that when the circuit is short, or when the circuit has some difficulties, right? If the current that is flowing in the circuit exceeds the rating of the fuse, it's now going to cause the wire inside here to break, right? And as a result of that, now it won't affect what is happening with your resistor or the other components, so to speak, right? So how it really works, guys, is by virtue of that wire inside getting too hot, and by getting too hot, now it breaks the bonds of the material that makes it. So we see where they said that a fuse connected in one branch of a parallel circuit, of course, would not affect current through any of the other branches. So yeah, because now remember, in a series, in a parallel circuit rather, current is divided, right? And if I only consider my fuse to be in only one of the branches, then it's not going to turn off all the components in the circuit, right? So we have to look into that part. Are there any questions? Are you understanding how the fuse work as what we were saying here?
Yes, sir, I get it.
Sir, the last part where you said if the fuse turn off something, I didn't get that part.
For the parallel circuit you're talking about?
Yes.
All right. So imagine, let me go back to this one. Imagine I have a fuse right here at this point of my circuit, right? Now the fuse here is going to break. Now it's going to stop the flow of current going through this light bulb. However, current is still going to flow through the other components. You understand? So only this one would be regarded as being safe, but the other ones now would be affected so much if the current is really high to damage these other components. So that's why we're saying if you have it connected in a branch, this would be a branch in a parallel circuit operation, it would only impact this light bulb, whereas it won't affect the other ones.
Oh, okay, sir. So it's better to use in a parallel circuit then.
Yes. So it's best when you connect it in parallel, and in this case, it will be best if you connect it like maybe right here, right? So if you connect it there, so because if I remove this thing now, well, if I remove this thing, if I delete this, then no, well, this is because this is the whole parallel circuit. It's still going to operate because as you can see a while ago when I removed this piece a while ago, it still operated. So it's clear that maybe that's not the right place to put it. If I put it in front of my battery source, then I expect now that it should stop, because once I cut off my battery source, right, then nothing can flow, nothing can work.
Okay, sir. So in a series, the entire circuit stop work with the fuse blocked down, right?
I didn't hear that.
I was asking that since that's a parallel circuit, if you put it a certain place, it's gonna still work because of the current splitting. But I was asking in a series circuit, the entire circuit locks down when the fuse blows.
Yes. Now, if you look at this thing here, you realize that it's in front of the battery source, all right? Now, let's talk some more about choosing an appropriate fuse. So, can somebody read this thing here for me, please? Somebody read that for me.
I read from where?
In figure 25.21a.
Okay, so in figure 25.21a, the total resistance of the current is 12 ohms, as the battery resistance is 1 ohm, and the lamp resistance is 11 ohms. When the switch is closed, the lamp lights. Applying the Ohm's law equation, V is equal to I times R, we calculate that the current in the circuit is 0.5 amps. This size of current does not cause overheating in the connecting wire. A fuse with a rating of 1 ampere will allow for the 0.5 ampere current to flow and keep the lamp lit under normal conditions.
All right. So if we look at this example here, right, we see where the total resistance, as what we said a while ago, is going to be 12. Good. Now, if we are supposed to calculate our current, right, based on our Ohm's law equation that says V is equal to IR, we would get a current rating at 0.5 amps. Now, that is a safe current to flow in your circuit, and it would not cause any damage. Now, they're saying that to choose the appropriate fuse, you would choose one that is above the value that we just calculated here a while ago, which is a 0.5 amps. So one of the best rating of fuse that you would use is a 1 amp fuse, because that is close within the range of you stopping damages that can take place to your light bulb. All right. Now, also know that, guys, this is another symbol, right? So remember the last one we see where it's almost like a squiggly line like this, right? Then now this is another one here that probably is more of the universal one, right? So just please bear that in mind, so that if you see it, you will know it's a fuse and not a resistor. Because typically sometimes they will use a box to represent a resistor rather than them having this kind of thing. So this is for the resistor, by the way. All right. Are we all on the same page, Joe?
Yes, sir.
Good. Now here is typically.
Sir, hold on. You can go back, please. Oh.
Hey guys, I must say something to you. If this meeting runs out of time, the second link in the group, that's the one we will jump to. You understand? Okay?
Okay, sir.
Okay,
Yes, sir.
All right. All right. So we can move down to the other question now.
Yes, sir.
All right. A 12-volt battery of resistance 1 ohms and connective wires rated at 5 amps are connected in series with a lamp of 11 ohm. Which of the fuse shown in figure 25.2 should be used for short circuit protection? Explain your answer. Now, let's see if we can attempt that question based on what we did initially for the first thing here. So, by the way, these are the resistors that we're talking about. Which one of them would be appropriate? Firstly, what do you think we need to do?
So we need to find the amount of current actually flowing through the entire circuit.
Okay. And what else do you think we need to find after that? So in order for us to find the current, what do you think we need to find the current?
So the total resistance and voltage in the circuit.
Good. So what will be the total resistance?
12, since it's only 2 components, 12.
12. So what would be the voltage now overall? It's not the voltage. Yeah, we know the voltage is going to be 12 volts. What would be the current?
Mm.